All right. Hello, everyone. Welcome to day one of new learning in geometry class. Today we'll be starting on lesson 1.1, and that is on page 4 in your textbook. And that lesson is called Points, Lines, and Planes. Again, this lesson is on page 4, so if you want to pull your textbook up and split your screen so you're watching the video and following along in your book, then go ahead and do that. If not, no big deal. But we are just going to work through some of the terms and definitions and some of the examples that the textbook has and kind of get a basis for this trimester. So a lot of the terms that we'll be looking at are things that hopefully will be pretty obvious, that they're not super mathy terms. They're terms that we are kind of familiar with, but it'll be important to be familiar with these terms so that when we talk about these things and talk about diagrams and shapes and things later, that we're comfortable using these terms, comfortable in the definition of these terms, and don't have to think too much about them. So with that said, let's take a look at our learning targets. The first one, I can name points, lines, and planes. The second one, I can name segments and rays. So those first two really just deal with definitions like I talked about. We'll go over those. I can sketch intersections and lines of intersections, and lines. Let's try to redo. Number 3, I can sketch intersections of lines and planes. All right, so we'll take a little bit of a look at intersections. And the last one, I can solve real world or real life problems involving lines and planes. Should say planes, period. Come on, there we go. Wake up. There we go. So those will be the learning targets for today, and we will review those at the end. First, the section starts out with going over what we call undefined terms. So these are terms, these 3 terms are things that we can't prove the definition of, but everyone agrees that a point on what we say the definition of a point is, a plane is, and a line is. And we kind of need to just assume that these things exist and these things are true in order to be able to give definitions for other things. These are kind of our rock solid assumptions, but we can't say that they are proved. And we'll talk a little bit about that in our next lesson and kind of give that idea of something we assume is true and is widely accepted as true. We'll give that a definition in the next section. But for now, let's take a look at these 3 terms. First one is a point. And the important thing that the book wants to point out or wants to show with a point is that it has 0 dimensions. And we're really familiar with this. If we see a dot, like we have here, a dot with a letter, we just know that that is point A. So a pretty straightforward definition there. Next one is a line. And the book points out, and we want to point out that that is 1 dimension, that a line is only 1 dimension. Now, when we're labeling and talking about a line, we see that first thing that has the arrows on both ends. So that means it technically continues forever and just keeps on going. When we name the line, you can see the cursive L. If you see a cursive letter, a lot of times you'll see M's or P's or things like that, and we can just call it line L, or if there was a cursive M, that lowercase m, we could call it line M. Another way that we could label it is line AB, and it has the line with the arrow on top of it. And that's going to be really important to not forget that line with the arrow, because we're going to have different terms where we have AB with just a line without the arrows, or just capital A, capital B, and they all mean different things. So we need to make sure we include that arrow on top. And then lastly, it could be line BA. The order there does not matter. One last thing about a line. Something that's important to point out is that a line is made up of not quite an infinite, but almost an infinite amount of points. So technically, this line has a bunch of points all on top of each other that all come together to make a line. And in between every point is another point, and another point, another point, and just infinite amount of points which make up a line. And we'll talk about later why that is an important distinction there. Our third definition here is a plane. And we want to point out that a plane is 2 dimensions, right? It's 2 dimensions because technically, I know we're not talking area and things, but technically a plane has an area, right? So that's what makes it 2 dimensions. Now, when we label a plane, we could call it just plane M, like you see up here in the corner. The M is not connected to a dot, so that's one of the labels we could put for a plane. We could also call it plane A, B, C. When we label a plane, we could call it by, one of the letters that it has up there that is not connected to a dot, or we could put together any 3 points inside of that plane. And the reason we need 3 points is because, let's say we only used AB, well, that would be a line, or maybe even a line segment, which we'll talk about later. So we need those 3 points when we are naming a plane. Let's take a look at 2 terms that relate to our plane. These 2 terms are collinear and coplanar. Now, just by looking at the root word, maybe not, it wouldn't be considered the root word, but a word inside of each of these things, we might be able to figure out what each of them means, and it might help us out to remember each of them. So collinear just means points that lie on the same line. So they kind of share something in common, and linear, the common thing that they share is a line. So if we have a line, let's say there are 3 points on it, A, B, and C, we could say that points A, B, and C are collinear. Pretty straightforward. Now with coplanar, points that lie in the same plane, things are a little bit different. This time, if we have some type of plane, points A, B, and C are coplanar. Okay, just because they're inside of, again, the same plane. If we had, say we had another point here, and it was point D, we would not say that ADB, that these are coplanar, because they are collinear, right? So it can't be the line inside of the plane there. Just 3 distinct points that lie inside of the same plane. So if we look up here, we have 3 collinear points, kind of just like what I drew. A, B, and C are all coplanar points. Now, if you're following along in your textbook, we're going to look to page 5. So you're looking on the other side, or maybe in your iPad, you have to turn the page. I'm not exactly sure how that works. But we're going to take a look at 3 different terms here. Now, like I said earlier, we had undefined terms, which were point, line, and a plane, things that we just assume to be true and that don't have a formal definition. Now we have defined terms. So we're going to take those undefined terms, those 3, point, line, and plane, and we're going to use those to define segment, ray, and opposite ray, and we can have a solid definition then for these 3 things. So first, a segment. We also could be calling it a line segment, and all that it means is that it consists of 2 endpoints. Okay? And the way that we would write this, the way that we would talk about a segment is that we would say this is segment A, B with just a line over top, no arrow. All right, so that's how we would talk about a line segment. Now, if we want to talk about array is something that has one endpoint and the other point is open. So as you can see here, A is an endpoint. There's nothing over here on this side of A. But then this way, it continues forever. Point A is the starting point, and then a line goes from there, or array goes from there through point B. So when we're talking about array, we call that array A, B. And notice that we have just an arrow up here on top. So segment, we have a line on top. Array, we have an arrow on top. Now if we had another array right here, oops, that's not what I want. And it was going this way. This time the endpoint is point B, and it goes through point A. Point or array BA is not the same as point AB, or array AB, excuse me. When we're talking about arrays, we have to be very careful with how we label it. We want to put the endpoint first, and then the point that follows, the point that the array goes through. So AB and BA are not the same thing. And that's different from a line segment, because with a line segment, we could call this AB or we could call this BA, and it would be talking about the same segment, but we cannot do that with array. Last one, opposite rays. So if we have a line right here, like we do in this picture down here, and there are 3 points on that line, A, C, and B, where point C is in between A and B. We consider opposite rays to be starting at point C and going through point A, so we would label that CA, where it starts at C and goes through A. And then the opposite of that would be ray CB, where it starts at C and goes through point B. Notice how, again, I always put the point, the endpoint first, and then the second letter, the second capital letter that is a point, is where the ray goes through, where the ray continues through. So there's a couple definitions there. A segment, just a segment, a chunk. A ray has an endpoint and continues through another point, and then opposite rays. Really, these opposite rays have a common endpoint. All right, they share an endpoint with those opposite rays. Now the last term for today is an intersection. Now an intersection, like it says in the dotted box there, is the set of points the figures have in common. So here we have two figures. We have line M, and then we have line N right here. In this case, the only point that they intersect at is point A. So we would say their intersection is point A. Now in this diagram, on the far side, it's a little bit more difficult to see, but we have a plane right here, and that would go through the back. And a plane here. Two separate planes, and they intersect here in the red. Now we can say that this is still an intersection, because remember, our definition of an intersection, the set of points figures have in common. And you might look at this red and you might say, hey, that's a line, not a point, so that doesn't count as an intersection. Well, remember that a line is made up of almost an infinite amount of points that make up that entire line. So really, we might call this, let's say we call this line M, really line M is made up of a ton of points. So we can say that the intersection of this green plane and the intersection of this blue plane would just be line M. That stretch where those planes meet. So let's really quick review our learning targets. I can name points, lines, and planes. Points. Remember, lines technically go on forever. We represent that with those arrows and then a plane. I can name segments and rays. And remember, with a segment, if it's AB, we just put a line on top. With a ray, if it starts at point A and goes through point B, AB with that arrow. I can sketch the intersection of lines and planes. You might not be great at doing this, but the plane is a little bit more difficult to sketch, but I think everyone can sketch two lines that intersect and then get close to sketching a plane. But we won't have to do that too often. And then lastly, I can solve real-world problems involving lines and planes, and that's what you're going to do in the practice today. So that's all that we have for today. Your job now will be to move on and work on 1.1